Let's look at proposition 3 of book 3 of elements. The proposition says that given a circle, if we have a line segment not passing through the center E, and we have another line passing through the center and intersecting this segment AB at right angles, then the line segment is cut into two equal halves. Or in other words, this line will bisect this line segment. The proposition also talks of the other way around. If this line segment passing through the center cuts the line segment AB by cutting it into two equal halves, then in that case the angle formed will be right. Okay, so we have to prove both the aspects of the proposition. So let's take it one by one. So let's join BE and let's join AE. Now here, if it is right angle, then these two are equal. The other is, if these two are equal, then the angle is 90 degrees. That is the right angle. So let's take one. Let's say it cuts this into two equal parts. So let's mark an intersection point. First, let's name these points at the ends of this line passing through the center. Let's mark them as C and D. And let's mark the intersection of the line segment with this line as F. So now the first part, we are given that AF is equal to BF. That is how this line cuts it. Then in that case, we have to prove that this angle is 90 degrees. So let's see. Looking at these two triangles, AEF and BEF, these two sides are equal. AE is equal to BE. Why? Because they are radii of the same circle. We are given that AF equal to BF and EF is the common side. That means using the SSS side proposition, we can say that these two triangles are congruent. That means all the corresponding angles are also equal. That means angle EFA is equal to BFE. And now, how do we prove that this is actually right angles? Remember another proposition which says that if a line standing on another line makes two adjacent angles equal, then they are right angles. So we have proved that these two angles are 90 degrees. So the first part is done. Now let's look at the second part, where we are given that these two angles are right angles and we have to prove that AF equal to BF. So now again, these two in triangle AEB, AE is equal to BE. That means the angles opposite to these sides are also equal. That means what? Angle FAE is equal to EBF in triangle EAB. Okay. So now coming back to these two triangles, we know that EA is equal to EB, radii of the same circle. We have these two angles equal. So using another proposition, we can say that these two triangles are congruent. And if they are congruent, that means all the corresponding sides are also equal, which means AF is equal to BF. So basically, we have proved that if a line passing through the center cuts a line segment at right angles, then it bisects the line segment. Okay, so that was proposition 3 of book 3. And remember, this line segment could be anywhere. So that means the point you choose, B, could be anywhere. A could be anywhere, except when it is passing through E, because then we will not have the triangles. Okay, so we could have A and B anywhere. Again, let me remind you that there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you like it, you can share it. That's it for now.